On page 46, we are going to finish our angle relationships with the practice section. So yesterday we talked about angle relationships. What is an angle, or adjacent angles? What are adjacent angles? Two angles that share a side. What are vertical angles? Good. Formed by two intersecting lines and they are opposite of each other. Complementary angles. Luke. So two adjacent angles that have a sum of 90 degrees are complementary. Supplementary angles. Gavin. So a sum of angles equaling 180 degrees. So we're going to use those principles, those angle relationships, to solve our practice section. At the bottom you'll note that there are 6 angles that we're trying to find. Let's start with EAF. Looking at our angles, EAF, angle EAF, what does that equal to? Jordan, 90 degrees. Make sure we're not forgetting our degree sign. So angle EAF is 90 degrees because we put this box, which is equivalent to 90 degrees. So that's angle EAF. Going down, FAD. Angle FAD. What is the measurement of FAD? If we're looking, angle FAD has been solved for us. It was given to us. So FAD equals 20 degrees. So we found EAF, that's 90. We found FAD, it's 20. Now let's look at DAH. So DAH is unknown. So the angle relationship that we're working with for DAH, what could that be? There are 2 types we could use. Paige, what is one of them? Vertical? Equal to EAC. So when it's vertical angles, it's where 2 straight lines intersect, right? We have a straight line here and a straight line here. The only 2 that would work for vertical were those. So this one right here and this one right here, they're not perfectly, they don't share the, they're somewhat, but they're not perfect, right? They're not, so they're not vertical, unfortunately, but there are 2 different relationships that we can use. What is one of them that we could use, Paige? We have a straight line. Thanks for phoning a friend. Chris, good job. Supplementary. What's another one, Luis? They could be adjacent, but what's one property that we could use that's nice? Colin? Complementary. Since this angle right here is 90 degrees, this angle right here is 90 degrees. So the angle FAH is 90 degrees because the straight line has to add up to 180, right? So we can use either relationship. Supplementary, let's just work with that one. So a supplementary angle for DAH has to equal 180 degrees. With this supplementary angle, this line EH, we know that EAF is 90 degrees. So we can put equals 90 degrees. FAD is 20 degrees, so we can put plus 20. And we can go ahead and call that X if we'd like for now. Or not X, let's call it Y, because we already have an X. So let's call it Y. Angle DAH or Y, so plus Y. So we can either subtract 90 and 20, or we can add 90 and 20 and then subtract it over. We can do whatever way works for you. We're going to go ahead and add first. So 90 plus 20 is 110. That equals 180 degrees. If we subtract 110 degrees from 180 degrees, we get 70 degrees equals Y. So we gave DAH the angle Y. So DAH is now equal to 70 degrees. So now we need to find HAB. HAB is 3x. We do not know x. They're not vertical angles. So what kind of relationships can we use? We can use supplementary, so that means we have a straight line here, right? CD is a straight line. Supplementary has y, 3x, and 2x. Y is 70, we know y. So how can we set up a supplementary angle equation, Skylar, to find DAH? So supplementary equals 180, right? We know y equals 70. We have 3x and 2x, so the same variable, right? So we might be able to use that to find x. Colin, you want to help us out here? We could use that. Yeah, so we can go ahead and once again use our complement or supplementary where we know that y is 70, so 70 plus HAB, which is 3x, right? So we have this straight line, DE or DC, y is 70, and we need to add these two, which we know will equal 110. So we have 3x plus 2x. Are we good so far? Are we following it? Have I lost anybody? If I've lost you, please let me know. Okay, so now we need to solve for x. So we subtract the 70 over, and as Colin said, 110 degrees. 3x plus 2x is 5x. If we're solving for x, we divide by 5. 110 degrees divided by 5 degrees equals 22 degrees. So x equals 22 degrees. So, as we learned yesterday, we can't just find x, right? We need to go back and multiply it by that number. So right now we're working with HAB. HAB is 3x. So 22 times 3 equals angle HAB, and that equals 66 degrees. Now we need, our next one is BAC. So we found that HAB is 66. We know that x is 22. So CAB, or BAC, is 44 degrees. So we take 2 times x, which is 22, and that equals angle BAC. And that, like you said, 40 degrees. Lastly, we need to find CAE. There are multiple ways that we can solve this. Hi, Colin. Skylar. Supplementary.
Yeah. Like going that way is like 180 degrees, and then you already know that that one's 90 degrees and that one's 20. So like you can just do like 180 minus 110 degrees.
So we've kind of already done that. So we can use supplementary. What's another angle we can use? Colin?
Well, pretty much just the bottom half. You can add 66 and 44 together, which is that is 100, and the only one left in that half is
66 plus 44 is
It's 110.
110.
So 70 degrees.
So it's still 70 degrees. So this one's 70 degrees. So angle CAE is 70 degrees. And DAH was also 70 degrees, right?
So there are vertical angles.
Which ones did you said FAD, didn't you? I heard FAD. I'm sorry, Paige. I'm sorry, Paige. I heard FAD. Good job. I just heard the wrong letters. It happens. That's very good.
I still.
So, to finish off, we found that CAE is
70 degrees.
70 degrees.
Then the packet.
So we've finished